Now let's look at broadcasting. We did look at this in the intuition video 2 videos back. Here we'll do the implementation of that broadcasting, and we'll create 3 tensors. First one is x tf.constant, and this can have values 1 comma 2 comma 3. The next one is y is equal to tf.constant, and this can have value of 10. And then we have z or z, and it has the value of let's put 5 comma 5 comma 5. And so these are the tensors we have created. If we now would if we now want to multiply this, so why don't we print this out so it's easy to see. Print, put line there, line, and this is x dot numpy. So we just see the array and the other details are not printed. Put a y there, put a z here, and this again would be y, and this would be z. This so error unicode escape. Oh, I forgot to put a n there. Okay, so these are the arrays or tensors we have. Let's now perform the operations of multiplication. So if we specify tf.multiply x comma 2 dot numpy, so numpy just so that we can see only the array part of the tensor. Here what we are doing is we're multiplying 1 to 3 by 2. So broadcasting is it knows that we need to multiply each element of the tensor by this number 2, and so we get the output 2. 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, and then we have the last one, 3 multiplied by 2 is 6. So that's one application where we can use broadcasting. And then the next one, by another one. So here we'll use simple operator. So if we specify x star y, sorry, small y, x star y, then we get the output where the numbers are 10, 20, 30. So what happened here was we multiplied the tensor x with the tensor y, which is just a value of 10. So 1 multiplied by 10 is 10, multiplied by 10 multiplied by 2 is 20, and 30, and so on. Similar to this, similar to multiplying a tensor with a number or a scalar, we can also multiply it with another tensor, such as here. So now in this case we have two one-dimensional tensors, and now we multiplied each of them by these numbers. So for sake of understanding, what we'll do is let's change this to 4, 5, and 6, so that when we look at the output of this x multiplied by z, we can see what multiplications are happening. So 4 multiplied by 1 is 4, 5 to the 10, and 6 times 3 is 18. So that's what we get here in the output. Next, let's look at how we can reshape the tensor, this tensor that we've already seen before, and revise what we just did. We can say if we were to reshape this, tf dot reshape, and we specify the value of x there, and as you know, we can input a list, and we specify 3 by 1. We are telling TensorFlow we need 3 rows and just 1 column, and so we get a vertical column vector or a tensor after reshaping it. Alternatively, we can also use a range object for creating tensors. So use range. This is similar to what is available in Numpy. So if we create a variable y, we say tf.range, and we specify the range from 1 to 5, and then run this, we get output tensor with values that start at 1 and go up to 5 but not 5. So stop at 4, and so here thus we get a one-dimensional tensor. And similar, and there is one additional point I wanted to show is there is a functionality that is broadcast underscore 2. So let's look at an example of how this would work. We have a tensor. Let's say if we have a tensor x, which is tf.constant, and it's a one-dimensional tensor, so 1, 2, 3, and we need to broadcast it. So let's create another variable y, tf dot broadcast underscore 2, and here we can specify the x, and now within this parenthesis we can specify the new shape for that particular broadcasted output matrix, what it we need it to be. So we can specify 3 by 3. What we are asking this function to do is take this matrix and put it in a form of 3 by 3, and the way it can do that, one way would be to take this and stack these rows on top of each other. So we have 3 rows of 1 by 2 by 3. Run this, and in the output we get 1 comma 2 1 2 3. So we get 3 rows of that particular tensor. So this is now a new tensor which is rank 2 tensor because it now has 2 axes. Moving on, let's look at how we can convert an array to a tensor. Add a heading, convert numpy array to tensor, and for that again we'll create two arrays, np.array, and here you can specify 1 comma 2 first row, and then 3 comma 4, that's the second row. Copy this, create another array which is y, and change the values a little bit so they are different. Change all of them, add a 0 in front of them. Now if we perform a dot product, which is if we do a np dot x comma y, we get an output that is as shown here. And to get the same output, we can use the TensorFlow library. So what tensor from, if we use matmul x comma y, we get the same output. Now the point to note in this case is that the x and y that are input to matmul function, they are numpy arrays. So TensorFlow can automatically detect and change it to a format of a tensor to perform this particular operation within function. Alternatively, we can do that manually. So if we were to convert x to a tensor, we would say tf.convert underscore to underscore tensor and specify x there, and then we have y underscore tensor is equal to tf.convert underscore to underscore tensor and specify y there. So now in this case, if we print let's just print x tensor, we can see that we should see that it's a tensor. So it is a TensorFlow tensor with of shape 2 by 2, and now we can perform the same matmul, that's the dot product x underscore tensor y underscore tensor, and we should get the same output of 70, 100, 150, 20, 220. So that's what we have with converting a tensor. Now let's look at the ragged tensor. RAGGD tensor. And here what we'll do is first create a list. So the list would have embedded lists which would be of different lengths. So 1, 2, 3, 4, that's the first list. The second list can be just 1, 2. The third list can be 3, 4, oh, sorry, 1, 2. The third list can be 3, 4, 5. And then the last list can be just one number, maybe 7. And when we run this, this is just a simple Python list. Now we'll use this list to create a tensor, and we'll see why this is not going to work to create a tensor, because of uneven number of elements within each of the list in that list. So if we say tensor x tensor is equal to tf.constant, and we say ragged underscore list, and then get x tensor, it'll throw an error, and we can see can't convert not non-rectangular Python sequences in the tensor. So that is something to remember. If we changed this, and just for example, if we change this and put if we put 4 elements in each of these, so let's say maybe 4, add 3 elements here. Now if we run this, this would work because it has equal number of elements in this particular list of lists. Now let's move that back to how it was. And so there is a method in TensorFlow which can allow us to create a tensor out of such uneven shapes. And to do that, we can use the method that is called tf.ragged.constant. So x_ragged tensor is equal to tf.ragged.constant ragged underscore list, and then ragged. So this is x comma ragged underscore tensor, and now we should be able to see, as we can see here, we have a ragged tensor created for us. But as you would expect, if we look at the shape of this tensor, if the shape will not be complete because it does not know how many columns to add. The number of rows is known, so we have 4 rows, but the number of columns is unknown, and so that's why we have a none here. Let's now look at how we can convert strings to numbers in TensorFlow. So a note here, we convert a string into bytes and then numbers. So let's create a string first. X underscore text is equal to tf.constant, and the string that we have is going to be numbers 1, 10, and 100 separated by spaces. So if we look at what x text is, so let me that x text. So it's a tensor, and the data type is string, and the shape is not there because it's just one string that we have. Now what we can do here is create another variable called xSplit. What that will do is it will take the string that we have created above and split it. So x underscore text comma split on space. So we are using this method tf.string.split, and within parentheses we specify the string and the separator to split it. Now after this, let's remove the space, and then we can convert this x underscore split to number. So x underscore num is equal to tf.strings.to underscore number, and we can input x underscore split here. Now if we go ahead and print all of this, so x underscore text, and so this is going to be x underscore text, then we have the x underscore split, and we have the x underscore num. So this is split, then we have x underscore num, which is this, and we have x underscore num. When we run this, we so we have an error tf.strings, an is there. So when we now look at this, with the original case we had x text, which was a tensor with with shape which was blank, and the data type was string. Then we split it, so we get this value, which is like a list in NumPy or list in Python, but this list has numbers which are strings, and that is denoted here by these quotation marks. And then we convert this using the strings to number command, and now we have this change to float. So we have gone from a string to a splitted string to float 32. And similarly, we can work with Unicode characters. So let's create an example. X underscore Unicode underscore bytes is equal to tf.constant, or special characters. Let's use maybe hash, dollar, and ampersand, sorry, at sign, and then percentage, and then output this x Unicode underscore bytes, and we get this output. Data type is string, and so in the, if you are in the docs, this is what I'm copying from the docs. If we replace this by this string that is from the docs, again you see that these are different characters, and there is a emoji there. So the values are different within this NumPy array. I'm going to switch this back to the characters that we are familiar with, which are these. Now let's split these. So again, you can call this x Unicode character in bytes is equal to tf.strings.unicode underscore split, and we can use the x underscore Unicode underscore bytes, and we can specify the type UTF-8. Now if we run this line of code and look at the output, we see that we were able to split this based on the spaces. So we have pound, dollar, at sign, and percentage sign separated in this array. And after this, now we can uh, use decode. So x underscore Unicode values is equal to tf.strings.unicode underscore decode, and this is x underscore Unicode underscore bytes, and then we have UTF-8. So these were converted into character bytes. Now we are converting these to unicode values. That enter. Here we have these values that are created, which is 1, 2, 3, 4, 5, 6, 7. But we just have 1, 2, 3, 4 values here. So I'm not sure what happened there. If we use these character bytes, we have same, we have 7 values. Um, right, so the shape here is 7 because we have 1. Okay, the space, we have this 7 because the space is also within that particular list that we have created right here. That explains that. We are good there. So that 32 represents the blank space. Now, finally, let's look at what are sparse tensors. And we did go through an overview of this in the very first video on tensors. Here we'll look at a concrete example. X sparse is equal to tf.sparse.SparseTensor, and here we can specify 3 items. Indices is equal to, then we need to specify values is equal to, and then we need to specify the final, which is the shape, dense shape. So what should be the final shape of this matrix or this tensor? So let's say we want to create a tensor that is 4 by 4, and in the at index 1 1 1 comma 1, we need to input, we need we need the tensor to have a value of 99, and at uh, at index 2 by 2 we need the tensor to have a value of 88, and here we are specifying that it's going to be a 4 by 4 tensor, or let's say 5 by 4 tensor. Then when we run this and create parse, so here, okay, this has to be within a list zone. So here we now have a sparse matrix that is created, and if we want to see the actual dense matrix, we can convert it to a dense matrix. So x underscore sparse, we can close this within parentheses and type tf.sparse.to underscore dense and run this. So this is the dense matrix that dense tensor that we have created, where we have a 5 by 4 tensor, 5 rows and 4 columns, and at index 1 1 we have a value of 99, at index 2 2 we have value of 88. And the reason why a sparse tensor, where a sparse tensor would be useful, is to save on memory and computational resources. If a data set has a lot of zeros and only few values that are non-zeros, then instead of storing the entire dense matrix, we can just store the indices and values at those indices in a sparse format as shown here. So that was it for this video on implementation of tensors in TensorFlow, where we looked at again how to create tensors. We looked at the shape, rank, broadcasting, and specifically we looked at different types of slicing and indexing, a rank 1 tensor or a rank 3 tensor, how to flatten the tensors, and so on. I hope you learned these skills and you are able to draw some parallels between how the tensors work and how the NumPy works as well. If you have any comments or suggestions, please let me know in the comment section below. I hope to see you all in the next video. Please like, share, and subscribe. Thank you.